What's up, algebra students? Algebra freshmen. I got mainly freshmen, yo, so what's up, freshmen? Listen, this is Algebra 1 Standard Honors Quiz 2. All right, here's the date, okay? And I am Mr. Miska. All right. Now, I don't know if you know this, but I've been grading this quiz today. I already got more than half of them graded. And I'm kind of down, man. I'm down in the dumps. Okay, so I'm gonna bust out this quiz for you and how it works, and I hope you pay close attention. Okay, as a teacher, you know when my students aren't successful, I feel pretty depressed. So like you know that's what this picture is right here. Um, and then, this is me, and I'm I'm a sad panda. All right. I'm a sad panda right now, okay? This is Miska, okay? These are my little teardrops. All right, this quiz makes Miska a sad panda, and it's not your fault. I just want to tell you, you have not been exposed to rigorous curriculum, but those days are over. So let's get started. First things first. You know, we always have a writing component in my quizzes, and this is the writing component to this one. I want it to go away. There it goes. All right. So I tried to tell you what I wanted in the question. I wanted you to explain PEMDAS to me, but you need to explain it to me as if I was a fourth grader. Okay, not as if you're explaining it to Mr. Miska, not as if you're explaining it to a math teacher, but to explain it to someone who doesn't understand. And I feel like some of you guys just ignored that part of the question. You know, because a lot of people wrote that it was, you know, PEMDAS, parentheses, you know, like exponents, right? Like that's this part. The 2 is the exponent. You know, multiplication, division, addition, and subtraction. By the way, this right here, this is why I don't use x for multiplication, because we use the variable x in algebra. So I usually represent my multiplication with a dot. So PEMDAS, yes, that is parentheses, exponents. That's this thing is the exponent, multiplication, division, addition, and subtraction. And some people, their whole answer, this was their whole answer right here. Okay, and they wrote out these things. They wrote out what they were. All right, but that was it. There wasn't any explaining going on after that. Okay, so that if you just wrote that, I gave you half credit, but I couldn't give you full credit because this right here, this you had a fourth grader. He's still going to be confused about what it is you're talking about, and that's how I graded it. I graded it as if I was a fourth grader reading your answer. So I put up here what I expect, or something like what I would expect up here. You know, it's a way that we decide the order in which we perform operations. It's all about order of operations. You know, you gotta crawl before you walk. And operations, that's that addition, multiplication, subtraction, division. You know, multiplication and exponents, they're tied very closely together. So that's like the same thing. So multiplication and exponential notation, that's kind of the same operation. So the order of operation, you had to have that somewhere in your like words. And if you didn't, I couldn't give you whole credit. All right. It's the way that we decide how we perform tasks, how we perform operations in a mathematical expression. All right, and then, you know, parentheses come first, followed by exponents, and then multiplication, then division, and then finally addition and subtraction. Okay. Next. And this right here, I'm gonna go ahead and do an example along with it. So we got to start with two fractions that do not have a common denominator. So we'll do 2 fifths, and we can do 3 halves, and we're adding them together. We can't add them together right now because they don't have a common denominator. All right, and a couple of people just wrote this. So my question is how how do you add 2 fractions that don't have a common denominator? And some people answered, well, you can't, and that was it. Well, I mean, yes, you can. We have to just do some stuff to it. We got to do some operations on these fractions, change them around a little bit, dress them up into different outfits. Okay, but we can add them. You don't just say here on my test, like, sorry, can't do it. Yes, you can. We learned it. I mean, we spent quite a bit of time on it. So don't tell me you can't do it, please, and let that be your answer, because I obviously want to know how you do it. And the first thing we got to do is we have to find a common denominator. And I'm not going to get down in the nitty-gritty about how you do this. If you want to know about how to find the common denominator, MISCA style, you can look at quiz 1. So the common denominator is going to be 10. All right? And I'm going to go ahead and draw that equal sign there, because that's important, because whatever we write up top, whatever goes here, what's important is this. The 2 fractions have to be the same. Like when we add the fractions on the left side together, once we know where these question marks fill in, if we add it up over here, they have to be the same. They have to be equal, equivalent. That's important. So let me go ahead and erase this right here. Okay. The common denominator is going to be 10. And what needs to change here is I can't have question marks. We have to have values on the top that make these fractions equivalent. So this is it right here. Once we decided on the value, which is 10, the fractions must be adjusted. So we already adjusted the bottom. We went from 5 to 10. We went from 2 to 10. All right? So that part's done. We did the adjustment for the bottom. That's what finding the common denominator is. But we have to adjust the top. We have to go from 2 to something. And from 5 to 10, that's times 2. So up here, we got a times 2 as well. And 2 times 2 is the same thing as 4. Okay? Then over here, I went with the 2 and multiplied it times something to get 10. And what I multiplied it was 5. So also I got to change this one right here the same way, times 5. If I multiply 5 times 3, I get 15. Whoops. I don't want to mess you up with the red, so make sure everything's in black. Some people will freak out. Why is it in red? Okay, now the fractions are equivalent. And the reason why is because I multiplied both fractions by the number 1. Let me write that in a different color here so it stands out. I multiplied this first fraction by 2 over 2, and I multiplied the second fraction by 5 over 5. Okay? 2 over 2 and 5 over 5, that's the same thing as 1. And 1 is the multiplicative identity. All right, once the fractions have common denominator, and they do, they have a common denominator. Now, once we do that, once that's done, the numerators can be added. And the numerators are these guys right here. Those 2 fellas. We can add them together. And 4 and 15 is 19. And the thing about it is, in fraction addition, we do not add the denominator. So the denominator just stays the same. This is what I was looking for, okay? And if you didn't have an explanation that went from the beginning, which is right here, by the way, here's the beginning. This is like St. Augustine, and let's say you want to drive to Miami. Here's Miami, okay? And here's your little ride. All right, like this, okay? It's a sports car, or maybe a minivan. All right, and you got your tires right there. And you go like this. If you couldn't make it from St. Augustine to Miami, here's Miami. You got to show me the whole thing. If you didn't make it here, then you didn't get full credit for this question. Like if your car broke down right here, you made it halfway. You got half credit. And even if your car broke down right here, you made it halfway, in my opinion, as far as how much credit you got. So please, please, You know, if I ask you how to do something, you got to go from St. Augustine all the way to Miami. You can't break down halfway. That's like I asked you to take me on a ride to Miami and you drop me in Daytona, okay? Well, that makes me a sad panda. All right, I don't want to be a sad panda. I don't want to be sad. I want to be happy. I want to be like, yeah, yummy, baby. Woo, yummy. Yay. All right, I'm here. We made it the whole way. We're so happy. Okay, we got to go all the way from the beginning to the end. You understand? Does that make sense? Please do that when I ask you to do something like this. Next. Oh, here we go. Here's the nitty-gritty now. Okay, now a lot of people knew what PEMDAS was. They at least knew that it stood for parentheses, exponents, multiplication, division, addition, and subtraction. They knew that. That's been ingrained in your brain. But the problem is that a lot of you can't use it, which is, it makes me a sad panda. Okay, I don't want to be sad. I want to be happy. All right, I want to draw smiley faces, and I want to put stars. Okay, like great job. That's what I want. And we're gonna get there. Okay, so if you're upset, you know, and you know that you kind of screwed up, you just need to pay a little bit of attention, because this is what we want right here. This is the good thing. Happiness. So, here we go. PEMDAS. PEMDAS works like this. And you know what? Before I even start, let's take a good look at this guy right here. Okay? What have I got here? First of all, I see parentheses, so I know I'm going to have to play with that a little bit. There is multiplication. There is division. Okay? So all these things are going to come into play. Where do we begin? Well, we begin inside the parentheses. What's inside the parentheses? We have -4 times a -4. Make sure you can see that dot. All right, and then this is minus 15 over 6 minus 1. A lot of kids came up to me and asked me about this minus sign, this one right here. What's up with that minus sign? Is it minus? Is it negative? Minus is negative. That's a complex idea, okay? I don't know, somewhere along the line, students of mine have thought up this distinction between the negative sign and subtraction. There is no distinction. It's the same thing. Okay, so you're going to have to like achieve some sort of mathematical nirvana by realizing that. Also, I want to point to you that we bend the rules of PEMDAS in my class. Okay, there's some subtraction right there. But, you know, when you see something that looks like this is a rational expression. That means it's like a ratio. That's from fraction. You know what I mean? Like a fraction is a ratio. It has a top and a bottom, and there's this ugly old division bar, you know, in between. When you have something like that, you can evaluate what's on the bottom and what's on the top. You could do that. That's safe. All right, you could do 6 minus 1, and nothing's going to happen. The world isn't going to collapse. All right, so let's do that now. 6 minus 1 is the same thing as 5. Okay, and this is still inside a little box here. All right, I just want you to see that. Now, I've been talking a little bit in some of my classes about algebra eyes. You will develop algebra eyes in my class, and algebra eyes, they're like X-ray goggles, and they see through math problems and start making shortcuts, and that's fine. What's the shortcut I see? What's 15 divided by 3? 15 divided by 3. That's what's inside this box, isn't it? Isn't that the same thing as 3? Okay, so inside this box, 15 divided by 3, that's the same thing as the number 3. So I'm going to put that in there. 3, okay? Now let's follow some more PEMDAS rules. I got to do multiplication before I do subtraction. I can't subtract until I multiply. And this is multiplication. This is 4, -4 times -4. A negative times a negative is positive. Okay? Negative times a negative is positive. Blah, blah. 4 times 4 is 16. So what you get is 16 minus 3. Now, some of my dudes and ladies, y'all wrote 13 as the answer. You wrote 13 as the answer here. Like 16 minus 3 is 13. That's true. But look, you forgot something. This is what's inside the parentheses. The parentheses. This is what's this. That's what that is. That's inside the parentheses. Look. Here's the parentheses, right? Here's the parentheses. There it is. But look at this. You forgot about this part. There's still a 2 minus whatever's in the parentheses. All this stuff, this is what's inside the parentheses. This is what's inside the parentheses. This is what's inside the parentheses. The parentheses boil down to 13. So what's left? What's left? What's left is 2 minus 13. And that's negative 11. Okay, take a deep breath. Number 4. All right, we haven't even gone into fraction time. We're not even in fraction time right now. We're still working with regular old numbers. If you listen to me, you know that I say if you have a rational expression, you can go ahead and do the type. You can let's just look at this. Let's just look at this rational expression right here. Negative 5 minus 3 divided by negative 4. If you take negative 5, right? All right, here's negative 5. And this is the number line. If you didn't know, now you know. That's the number line, yo. And you have negative 5, and we go in the negative direction, which is this way. 3, 1, 2, 3. That's negative 6 right here, negative 7 right there, and this bad boy is negative 8. So on top, negative 5 minus 3, that's negative 8. And then on the bottom is negative 4. Well, a negative divided by a negative is a positive. And what's 8 divided by 4? 2. Okay, so this right here is 2. This is just the number 2. So I'm going to go ahead and rewrite it. Here, this can go away. Go away. Yeah, I'm getting better. I've been practicing. Getting stronger. Won't be longer. That's from Rocky, yo. So I got 2 after a parentheses. I got a minus, a minus. I hate that. We're going to talk about that next. And then I got my 2 here, and I got minus 5. Okay, this is times 2 minus 5. Okay, now look, I broke a PEMDAS rule. I did some division before I did what's inside the parentheses. But that's because Miska told you, yo, Miska told you, if you got a rational expression, and that's what this is. That's a rational expression. You can go ahead and see what it turns out to be. Okay, that's how we skip it. We bend the rules. We do division first a little bit. Okay, now let's go ahead and look at this. Let's go ahead and look into the parentheses. Okay, and if you start parentheses first, that's fine. What's plus a plus? I got a guy in my class, and he broke it down real good. Same sign, you get a positive. Different sign, you get a negative. So a positive times a positive is positive. There ain't no way you can get a negative out of 2 positives. It's just not going to happen. But the same sign here is also going to make a positive. Look, it's almost like a sad panda right here. Like, look. That's a sad panda. You know what I'm saying? And there's a little panda eye, you know, and there it is. Sad panda's popping up all over the place in this quiz review. Because that's what I am. That's how I feel. I can't hide how I feel. It comes up in my writing. I can't even help it. So 2 minus a minus. There it is again. Sad panda. That ain't right, yo. A minus is the same thing as plus. So, yo, here, let's do it. It is the same thing as plus. You rewrite that. You rewrite it. Use paper. Some kid asked me in class today, is it all right if I get another piece of paper for scratch? Yeah. What do you mean, is it all right? Yes, it's all right. Get out 15 pieces of paper. Why don't you get out 100 pieces of paper? And then you'll be prepared, all right? If you feel bad about the trees, buy recycled paper. Or get a dry erase board that you can bring to class to do your work on, okay? 2 plus 4 is 6. I know you can do that. Times 2 minus 5. Now here in America, we read from left to right. And this is where PEMDAS comes in. All right, this is where it's important. Because you may want to do something that isn't going to work out. In this case, left to right does work because what comes first? Multiplication. Multiplication comes first. There it is. Multiplication. That dot represents multiplication. Okay? There it is, that dot. So we can. 6 times 2 is what? 12. What's 12 minus 5? Well, what's 12 minus 5? If you don't have a calculator, I know this is a tough one. 12 take away 5 is 7. And that's the answer to this problem. The number 7. 12 minus 5 is 7. Okay? All right. Next. Oh, fraction, Jackson.